Hi all, so we're now up to talking about something called a hyperbola. Hyperbolas are really cool functions. They look something like this, and due to their unique shape, they're actually used in a lot of things. So they're used in satellites. We often make heavy use of them when you're launching a satellite. You first got to use a mathematical equation to predict the path, and because of the gravity influences of objects with a heavy mass, the path of the satellite is skewed, even though it might initially launch. So using a hyperbola, you can predict the path of the satellite. It's also used in radios. So in radios, they employ hyperbolic functions. Scientists and engineers establish radio stations in positions according to the shape of a hyperbola in order to optimize the area covered by signals from stations. It's used in lenses and monitors, microscopes, telescopes, televisions. Your eyes have a natural focus point that doesn't allow you to see things too far away or too close up. And when you such things as planets or bacteria, you have these objects that focus light into a single point, and the designs of these use hyperbolas to reflect light to the focal point. So there's lots of different uses of hyperbolas, which is one of the reasons they're quite so interesting. You don't need to know any of that, but it's useful to know the background. So if we're talking about hyperbolas, we first think about the concept of inverse proportionality. And inverse proportionality, you might have seen it in science, for example. If you have the equation force equals mass times acceleration, you could then say mass equals acceleration divided by force, and therefore you could say mass is inversely proportionate to force. Okay? Mass means if the mass goes up, the force goes down. If the force goes up, the mass goes down, to keep the same acceleration, for example. So inverse proportionality is just simply that two variables are inversely proportional if multiplying one variable by a number actually results in the other being divided by the same number. We're on page 9, in case you were wondering. So it results in the other being divided by the same number. Okay, so we have an example here of y equals 1 over x. In other words, y is inversely proportional to 1 over x. And we get this graph, a graph that looks like this. Now, you should be able to notice a few features of the graph. And one of the main features are these little features that you see around here. As you can see, that graph approaches the x-axis, but it never actually hits it. And if we were to zoom out on that, we would see that the graph would get closer and closer and closer to the x-axis, but it would never actually hit it. And that is because there's a horizontal asymptote there. Similarly, up here, we can see the graph gets closer and closer to the y-axis, but again, it never hits it, and that's because of a vertical asymptote. So we have these few definitions here, which you'll need to understand. Horizontal asymptotes are horizontal lines that the graphs of functions approach but never reach as x goes to or tends to infinity or negative infinity. They're parallel to the x-axis. So in this case, this function, if we drew this out, would keep on getting closer and closer and closer and closer to the x-axis as x gets bigger and bigger and bigger to infinity, but it would never actually reach it, and same on this side. So that's a horizontal asymptote. And then a vertical asymptote is exactly the same thing. They're straight lines of the form x equals something, whereas a horizontal asymptote would be a straight line of the form y equals something. But as x approaches this constant value, so in this case as x approaches 0, then f of x or y goes towards infinity, and it goes up and up and up and up, but it will never actually cross. Okay? So for those values of x, say at x equals 0 in this case, we say that the function or the y value is unbounded or undefined. We do not define the function at that point because there's asymptotes here. And when you have hyperbolas, you will always have asymptotes. So this graph here, y equals 1 over x, is a special type of hyperbola, because hyperbolas have this form down here, y equals a divided by x take b plus c, where a, b, and c are constants. Alright, so in this case, when we've got y equals 1 over x, a would equal 1, B would equal 0 and C would equal 0. Okay? So if A, or the number on the denominator, on the numerator, the top line of that fraction, so that number there, if that is positive, the hyperbola lies in quadrant 1 and 3. But if it's negative, the hyperbola actually lies in quadrant 2 and 4. So that graph up the top, if we had y equals negative 1 over x, it would look like this. Obviously getting closer to the x-axis and the axis, but it would look like that. That's the graph of y equals negative 1 over x, because the a is negative. Rightio. Now, the equation of the horizontal asymptote, so we can tell that straight off the equation that we get, that is always going to be y equals the value of c, and whereas the equation of the vertical asymptote is going to be x equals the value of b. And in case you're wondering, hey, we had two c's up here, those c's are nothing to do with the equation, they're just talking about a constant value. Okay, so it's always going to be in the form x equals a constant, y equals a constant. But if we're relating it back to this equation here, the horizontal asymptote is y equals c, and the vertical asymptote is x equals b. But this is going to make a lot more sense when we do an example. So, here's our example. So we've just got some steps here when we're drawing hyperbolas. It's actually not that hard. The first step is to ensure that the denominator has the coefficient of x factored out. Now that might sound like gibberish, just write it down for now, we'll talk about it. Okay, step 2, plot the x and y intercepts. Step 3, drawing the asymptotes. Remember, we get the asymptotes straight off the equation. And step 4, plot 2 additional points. Now, that's if the question says to draw. So there's a difference in method in questions between draw and sketch. If it says sketch, all you have to do is these first 3 things. If it says draw, you actually have to plot 2 extra points. So just remember that. Draw is more specific. Sketch is what it sounds like. It's a sketch. Okay? So, here's our example. Let's sketch this hyperbola. 1 over 2x take 3 plus 2. Now, we said factor out the coefficient of x. We're going to do that, but we're not going to use that when we're doing our x-intercept. So we're just going to factor it out. That's going to give me 2 outside x take 3 on 2 plus 2. Might seem like a weird thing to do, but we need to make sure inside that bracket we have that coefficient of x being 1, because that affects what the asymptote is going to be. Right, so that's step 1. Step 2 is plot your x and y intercepts. So remember, the x-intercepts are when y equals 0, and the y-intercepts are when x equals 0. So y-intercepts are often easier to find than x-intercepts, so we're just going to find that by substituting in x equals 0. So y is going to equal 1 over 2 times 0, take 3 plus 2. I wouldn't bother about substituting it into the form that we created over here. It's just as easy to do it in this form. So we're going to get y equals 1 over negative 3, or negative a third, plus 2. And so y is therefore going to equal 1 and 2/3. So our y-intercept is going to be 0, 1 and 2/3. As we said before, make sure that you write your y-intercept as a point. Then your x-intercept over here is going to be when y equals 0, so you're going to get 0 equals 1 over 2x take 3 plus 2. We just rearrange that equation in order to find what x is. So we're going to multiply both sides by 2x take 3. And we're going to then expand that bracket. Negative times negative is a positive. So negative 2 times negative 3 is positive 6. Equals 1, take 6 from both sides, and then divide by 4. And remember, negative divided by a negative divided by a negative is a positive, so you're going to end up with 5 over 4, and our x-intercept is going to be 5 over 4, 0. So we've done step 1, and we've done step 2. Step 3 is to draw in the asymptotes. So to draw in the asymptotes, we have to work out what they are. And remember, we said that from before this tells us what the horizontal asymptote is, and this tells us what the vertical asymptote is. So in this case, if we're doing in step 3, and you can hopefully write these steps a little bit more linearly under each other, you're going to get your horizontal asymptote as being y equals 2, that's the horizontal asymptote, and your vertical asymptote then is going to be x equals 3 on 2. And that will tell us all the information we need to know to sketch it. And again, if we were going to draw it, we would just find 2 more points. So when we've got that, just a quick point with our general equation, and let's write it in the form as we did before, a over x take b plus c. Just remember it has to, the denominator has to be in that form. So if you've got something like 1 over y equals 1 over x plus 5 plus 3, we have to write it in the form minus something. So we write it as y equals 1 over x minus minus 5, using the fact that 2 negatives make a positive. And then that means that this part here, the negative 5, is your asymptote. So just remember that. It wouldn't be positive 5, it would be negative 5 in this case. That's just a quick extra point. Always make sure, if you're trying to work out the asymptotes from this equation, that it's in the form x take b. Alrighty, so let's draw our hyperbola. I'm going to do it over here on the side, but hopefully you've got room on your graph paper. We've got to draw our axes, y and x. We're again going to draw our scale, and I'm going to go with 2 again, but you don't have to at all. Just make sure you've got one point at least plotted in those 4 positions. So we've got our axes drawn, we've got our axes labelled, and now we're going to draw in our asymptotes. So y equals 2, that's going to be a horizontal line through here. And always label your asymptote, so that's going to be y equals 2. And then x equals 3 over 2, so that's 1.5, so it's going to be about there. We draw them in as a dotted line, as you can see. X equals 3 over 2. So draw in your 2 asymptotes as dotted lines, and then we're going to plot the x and y intercepts. I could have done that first, it doesn't really matter which order you do it in. So we're going to do 0, 1 and 2/3, so x is going to be 0, y-intercept is 1 there, so about 2/3 there. And then x-intercept is going to be 5 over 4 zeros, so that's 1, 5 over 4 again, it's about there. I did negative 5 on 5, it's on the other side. 5 over 4, so it's going to be about 1.25, so it's going to be about there. Alright, so we've only plotted 2 points, that's fine. That's going to tell us the shape of that side. Then the shape over here in quadrant 1 is going to be mirrored to that. So then I just have to connect it up and do my shape where I know that it's going to be in this side because of the positive numerator. Try and make it. Remember, you're going to make it so that it looks as like it will come really close to that line, but it won't cross it. Don't make it look as if it could cross those dotted lines, because it can't. Right, and then we just draw this in here. Hopefully a bit less shakily than that. Okay, and then you've got your graph. So just remember those steps, and then you'll be fine with hyperbolas.